Okay, here we go. An example problem for parallel circuits. Okay, first off, recognize this is a parallel circuit. There are three we call loops here. Electrons will leave the negative terminal. They will go this way. They go here. They come here. This is called a junction, where some current will go to the left through the 5-ohm resistor into the battery. Some current will come straight into the 7-ohm resistor into the battery, and some will go to the right to the 9-ohm resistor. They meet up at junctions. Okay, these places here are called junctions, and here junctions. And the key thing, Kirchhoff's rule, the current into a junction equals the current out of a junction. So some is going to go this way, some is going to go that way, some is going to go that way. All that's coming in is going to equal the sum of that's coming out. All right, but first, let's figure out question A. What is the overall resistance? Resistance in parallel circuits is a little weird. Resistance in parallel circuits, the equation for resistance in parallel circuits, 1 over parallel, the resistance in parallel equals the sum of each resistor individual. So 1 over Rp is equal to 1 over, let's call R1, plus 1 over R2, plus 1 over R3. So in this case, the resistance of the parallel circuit would be 1 over 5 ohms, plus 1 over 7 ohms, plus 1 over 9 ohms. It is my experience that most students hate fractions, don't like working with fractions, so I'm going to tell you, don't work with fractions. Turn these all into decimals. 1 over Rp equals 0.2 ohms, that's 1/5. 1 over 7 is 1.143, plus 0.143 ohms, and 1 over 9, 0.11111, 0.111 ohms. That will leave us with 1 over Rp to be equal to, add those up, 0.2 plus 0.143 plus 0.111. We get 0.454 ohms. Do a little arithmetic. The reciprocal of that, Rp, there's a button on the calculator for reciprocal, x to the minus 1 equals 2.20 ohms. The symbol for ohms is the Greek letter omega, right? So there's how you come up with the answer for number A. The strange thing here is that each resistor, 5 ohms, 7 ohms, 9 ohms, is more than the equivalent or total resistance. That's kind of strange. The more paths you give for the electrons to flow, the overall less the resistance becomes. Now, the next question here, B, is what is the overall current? All right, simple. Now that you know the overall resistance, go to Ohm's law, V equals IR. It's an 8-volt battery. They want to know what's that. So if this is the overall potential drop, they want to know the overall current. We have to use the overall resistance, which we just figured out was 2.20 ohms. So I equals 8 divided by 2.2, or 3.64 ohms. Oh, no, sorry, not ohms. What am I saying? Amps. Current is measured in amperes. All right. What's the voltage across each resistor? This is one of the rules that you must know. Each resistor, or I should say each loop, really should be each loop gets the voltage of the battery. So if you were to add a voltmeter over here, and you were to add a voltmeter over here, or over here, anywhere you get the same answer. And every voltmeter gets, every loop gets 8 volts. All right, so there's C. D, last problem. All right. Here, apply Ohm's law to each resistor. V equals IR, but you can calculate V1 equals I1 R1. V2 equals I2 R2. And V3 equals I3 R3. What does that mean? V1, every voltage is the same. So that's going to be 8 volts equals the current through the first resistor, and the resistance of the first resistor was 5 ohms. So I1 is going to be equal to 8 divided by 5, or 1.6 amps. 1.6 amps. What is the current through this second resistor? I'm calling that one the 7 ohm resistor. Again, every loop gets 8 volts. The current is what we want to know, and we're told it's 7 ohms. So I2, the current through that resistor, equals 8 divided by 7, or 1.14. And third one is 8 volts equals some current through the 9 ohm resistor. 8 divided by 9, 0.89 amps. Now this should make sense. This is the 9 ohm resistor is the most difficult thing for the current to pass through. So because it's most difficult to pass through, you get the smallest current going through it. The 5 ohm resistor is a whole lot easier for electrons to pass through, or charge to go through, so more current goes that way. Right? Through the first resistor, 1.6 amps goes in between here. Electricity is lazy. You'll hear me say in class, electricity is lazy. It follows. If there's an easier path, it takes the easier path. So more charge goes through the easier path than through the difficult path. That's pretty much everything in this problem. If you notice, if you add up, go back to Kirchhoff's rule of junctions, if we have 3.64 amps coming into this junction, if you were to sum 0.89, 1.14, 1.6, if we do the sum of all of those currents, 0.89 plus 1.14 plus 1.6, we get 3.63. There's a rounding issue for whatever reason, but hopefully you recognize that current in will be equal to current out. Okay, you should get the same results. I think it's right here. This is a little bit more, and I just chopped it off. But that's how it comes up.